All right, so for version number 1, we want to handle the exception in b.mb, right? So for now, I'm gonna switch just between the slides, just the iPad, and also Eclipse to show you the individual versions. But you can also go over the slides. You also got some written notes over there for you to read. So let me just put iPad over here, okay, just to set it up. Okay, let me now try to develop version number 1 together with you from scratch. And the you already got you can download this Java project over here. You can import it to your workspace. It's called exceptions to handle or not to handle, right? We're basically saying for each level of the caller, it is facing an option to either handle the exception by catching it or not to handle the exception by specifying it. So that's the version we would like to see. Let's now try to develop the first version. Okay, so if you open that, in your case, you might have got all the 3 classes already, but for me, I just make it empty so I can develop from scratch together with you. So let me say I want to create a new class under package version 1, and then I will create a class called A. Okay, it's pretty much like a model class, so there's no main method over here. Okay, so now let's say for A, we simply got the default constructor. I just defined that explicitly, default constructor. And let's not worry about the methods being public. Okay, let's not worry about it. We'll just put everything into the same package. And let's have a mutator here. Let's say void MA. Let me just maximize it. MA and also integer I. So input I will be the one to actually tell us whether this will actually be the one to decide whether there should be an error. Okay, and then like that. Okay, now we say if I is strictly less than 0, so this will be the error case. Okay, so now we want to handle this exception. Let's give some comments over here. To handle this exception, which we're going to throw below under this circumstance. Below, we choose to specify it as opposed to catch it. Okay, typically, in the very original method that actually throws the particular exception for the error, you don't actually try to catch. You don't try to catch it at the same time. You don't, because you want to throw it and catch it at the same time. You're not really propagating that to the caller for handling. That's not a typical way to go. So that's why I don't really discuss this. Didn't really discuss this earlier. So my point is, if we are talking about the method where the exception is originated from, in that case, you always just choose to specify that, which I will do in a moment. So now, how do we say we want to actually throw that exception, right? So we need a new keyword. We can say, well, let me show you the slightly wordy way to do it, and I'll show you how you can just simplify that into a single line. So we'll say the exception name I want is negative value exception. So negative value exception. Okay, so this is what I want, and I will say throw new negative value exception, and then typically I should really give some error message here. I know that this is right underline, I know that, but just leave it just over there. And then I'm going to say negative value and then plus I, right? So this is what you should do whenever you want to actually throw an exception. So throw is a new key, is a keyword that you should know. Notice that it's a verb, so there's no S after that, right? We're saying just throw it, okay? And then new, so there's like anonymous object, which we also spoke about before. We are creating an object of type negative value exception, okay? So now under this context, if we move our cursor over the negative value exception, it's going to actually suggest some solution to it. And you can see create class negative value exception. So that's really the option to choose for Eclipse to generate something for you. Okay, if you click on that, okay, you can see here it's going to be generated under package version number 1. And then notice one thing that's really important. Every exception class that you're going to create is a special one that should has a superclass called Java.Lambda exception. We'll speak about superclass a little bit later, but you can think about if I say my superclass is an exception, I'm really indicating to the compiler the class in this case, negative value exception is a very special one to actually that must be handled by either catching it or specifying it. It will be subject to the catch or specify requirements. Okay, it's really important. Okay, you can see the name. You have no choice. It's gonna be negative value exception here, and then nothing else you need to do. Just the only thing you want to check is the superclass is actually java.lambda exception. Just make sure. All right, and say finish. All right, so let's see what has been done. If you go back to the package explorer under version number 1, we got negative value exception over here. It's been created. However, the only thing you need to do over here, let me show to you something we have to type together. Okay, because the kind of constructor I have chosen is not the default one, it's the overloaded one, which will take a string value. It's more like a message for the exception. So I need to declare this constructor myself, which will be quite easy. I can simply say negative value exception, right? Of course, it should be public over here, okay? You might see for version 2 and version 3, I may not have the public in front. You can add it yourself, okay? But the constructor should be public. So negative value exception, and then it's going to take some string s, and then here I'm going to write something that we will speak about later. For now, you can just take it for granted. Okay, super s. Super, to be more precise, super is actually a keyword for calling the corresponding constructor in the superclass. In this case, the exception class. We are saying that we want to create this overloaded version of the constructor, which will take a string value, and the way we implement it is by simply reusing whatever version that's in the exception class, which is a superclass. And the way you invoke the version in the superclass is by using the keyword super. We'll talk about the super keyword when we talk about inheritance later. Okay, for now you don't need to worry. And also you got some warning here. You can see some yellow underline. The serializable class, whatever, right? That's the error message. You can easily suppress that by doing the following. You can just move your cursor over, and then you can say, you can choose over here, add suppress warnings serial to negative value exception. If you click on that, it's now fine. Okay. Do you need to memorize this constructor here? Absolutely not. You don't need to memorize it. So you should really make this as a reference point whenever you need to create an exception. Let's say either for your laboratory exercise or for your programming test, you are allowed to actually refer to an exception class like this, and then try to see how to define the constructor. It's very standard. Okay, there should be no surprise in terms of how to create the exception classes. All right, let's go back to A over here. We already got the exception class. So now here we have one issue over here. You can see throw new negative value exception. What it's saying is on handle exception type negative value exception. Basically, it is complaining the following. In this method a.ma over here, one exception of type negative value exception is thrown. However, no one is handling it yet. So now we got two choices. Remember the catch or specify requirements. So now we either need to catch this exception here, or we need to specify the exception. If you want to catch it, this is how you do it. You might say try. You can enclose the exception here, and then you can say and catch negative value exception. Again, negative value exception. Just give a name to the parameter, and then do something like that. So this will resolve the compilation error. However, as I said, if we are now in the place where the exception was originated, usually you don't really choose the try and catch option because it doesn't make sense. In some ways, it's kind of useless. You're throwing this exception over here because you want somebody else, like a caller, to actually handle that, but you're handling that right away. So what would you do? If you simply just do something over here, so why do you bother with the try and catch block in the first place? Why don't you simply put whatever that's inside the catch block? For example, if you want to say, I want to say system, maybe I want to do some computation. Okay, let's now write the console messages. Let's not. So you will do some computation to repair or to inform the user. Okay. However, if this is what you want to do once the exception is caught, why don't you simply just get this line over here and then get rid of the try and catch and just put this line over here, right? just say computation to repair or to inform the user. Why don't you just put those lines in the first place? There's no need to do try and catch, right? So this is why I just mentioned that typically in the same method where the exception was thrown, you don't really do try and catch. That's not the option to choose. Okay. Instead, you will try to specify it and propagate this exception to its caller. That's what you will do. All right. So let me just mention this over here. Okay. Let me just put this into comments, and then I will show to you what you should do. Okay. In the method where the exception is originated, we don't catch it. For the reason that whatever you put in the catch block could have been just put by itself without a try and catch block. So that's really what I meant. All right. Okay, that's the comment I would like to leave over there to remind you. Let's just put throw new negative value exception back. Okay, let me just copy this. Okay, just to save some time. Oops. Okay, so now what should we do? If the catch is not the way to go, we should specify. The specify is going to involve another keyword that's going to be part of the header, right? Should notice that the header should be in between. The place to put should be in between the closing parenthesis and the opening curly brackets, right? So now we're going to say throws, right? We spoke about this keyword as well in the earlier video. So we'll say throws negative value exception. That's what we'll put over here. So what this is saying is this method here, for any caller of this particular method, they should be aware that calling this method here may or may not get the negative value exception thrown, depending on the input value over here. It may be if the I is strictly less than 0. So that's why we said this is specify option. You can see if we take this option here, we don't need to worry about handling this exception to do something over here. We don't need to, right? We just simply just throws to include in as part of the header to say this method throws negative value exception. And one thing to know that can be confusing. This is throw, this is throws over here. So you can think about this is more like a description about this method throws negative value exception. And this is more like an action to say now I want to throw this exception to the runtime execution system. All right, so that's about this. And then otherwise, if the I is not strictly less than 0, we can do something else. And I'll just indicate that. You can just for this example, we don't need to worry about what something else we should do. Just say do something else when there is not an error. All right. So hopefully you're okay with the class A so far. So now we need to declare some caller which will call a.ma. In that case, that caller will be facing the options subject to the catch or specify requirements. Let's take a look. Okay, let's now go back to version 1. Let's now say new class, and then I will put B over here, right? Okay, what about class B over here? Let me just go to look at my notes over here to see what to put in B. Okay, and for B, again, we're going to declare some default constructor over here. And then let's say void, and then let's say method mb. Okay, integer I. Okay, also some integer input. And then I would say in order to be a caller of a.ma, we need to create an object of type A. AOA is assigned to new A. Okay, so now let's make some notes over here. From the method call below, we know from its header that b.mb is the, we know two things actually. Let me just go one by one. We know two things. Number one, okay, this will be number 2. Okay, number 1, b.mb is the caller of a.ma. Okay, first of all, let's see what the method call is. I'm gonna say oa.ma, and then I'm gonna give some value. Whatever value b was passed, b.mb was passed, I'm gonna pass that directly to oa.ma over here. Okay, so first of all, we know that this b.mb is actually a caller of a.ma, right? It's consistent with how we define the caller-callee relationship. Okay, so that's the first thing. And second thing, from the header of b.mb, it may throw a negative value exception, which must be handled. All right, let me maximize it to grab more space for us. Okay, so these are the two important observations over here, right? And for observation 2, it's now really talking about the catch or specify requirements, right? So this will be catch or specify requirements. Okay, let's say for version 1 we decide to catch it. We want to handle that exception right here in the caller, right? Remember the call stack over here. A.ma is the method that throws the negative value exception, and then when the exception was propagated to b.mb, we choose to catch it rather than specifying it. If we specify it, which will be version number 2, it's going to be propagated further to tester.ma, but that's what we'll do later. Okay, let's just worry about version 1. Okay, so what we'll do is in this version, we choose to catch it. Okay, how do we catch it? We're going to surround the method call over here by try and catch block. Okay, so it's going to say try over here. Okay, just say try, and then you can cut and put it here and catch. And the type that we aim to catch should be matching the exception that might be thrown. Let's look it up. What might be thrown? If you go back to the callee a.ma, as part of its header, negative value exception is the one that can be thrown. So you will simply copy that, right? Simply copy that and go back to B over here, and you will paste it over here. Paste. Oh, sorry. Just paste it inside over here. And then negative value exception, just give a name over here. And what about the action over here? So I say do something to handle the exception. One thing to note, remember the normal versus abnormal flows, execution flows I spoke about before. In the case where the exception was actually thrown over here, the rest of the try block is going to be bypassed. That means the execution flow will be interrupted. So we'll just go into the catch block. So what can we do in the catch block? Interestingly, one typical thing to do in the catch block is actually to put some console messages. Okay, so it is okay to combine exception handling together with console messages in the catch block. That's okay. On the other hand, if you don't use the try and catch block, but only to use the console messages to do error handling, that alone is not appropriate. Okay, I want to clarify. All right, let me go back to the iPad. Oh, sorry, go back to Eclipse. And let me say sys out over here from b.mb, just to say where we are catching this error. So this is the caller where we're catching this error, negative value, and then plus I. All right, so that's what we can do. All right, so that's about handling the error. And as soon as this exception is handled, so that means it will not be propagated any further. Okay, it's really important to say that. So let's say once the negative value exception is caught here, any further caller of b.mb, so we are talking about this method here, any caller of that will not be subject to the catch or specify requirements. However, in version number 2, you will see that if we actually opted for the specify options, in that case, the caller of b.mb will be subject to catch or specify requirements, right? So that's why you really want to study the different versions carefully to see what the difference is. All right, so that's B. Let me create one more class. Okay, let's right click on version 1 package, and then we'll say class. And the one I want to create is called tester. All right. And this is a console application I would like to have, right? You might be wondering, well, we are not having console apps, applications, JUnit tests, and also model package, like a separation of concern like before, but that's okay. I mean, for this one, it's more important to organize the classes in terms of version 1, version 2, and version 3, and to explain the call chain. So let's not worry about the separation of concern you learned from the earlier review tutorials, tutorial series. That should still be the common practice you should really adopt. Okay, let's now take a look at the tester. Let's see what we should do. And the way you should do that is simply say scanner input is, okay, let's just make sure we got a scanner, right? Control space, scanner from java.util. Let me just maximize the tab. Input is new scanner system.in, and then we'll say system sysout over here. Let's say enter an integer value I. Okay, like that. And then we're going to read from the keyboard. And so it's going to be integer I is assigned to input.next int over here. Okay, let's now make tester.main the caller of b.mb. Okay, so what I will do is I'm going to say bob is assigned to new b over here, and then we're going to say two things. Let me just copy and paste a little bit from before. Okay, if you don't mind, let me say that. Okay, for this particular version, we can say Control A to Control Command A to select everything, Control or Command I to fix the indentation. Okay, from the method call below, we will know. Let me just fix that for you. Tester dot main is the caller of b.mb. I'll show it to you. I just want to fix the comment quickly. From the header of b.mb, it will not throw. It does not throw any exception. In this version, okay, this means, okay, let me just, this means tester.main is not subject to the catch or specify requirements. Okay, I'll just do that in a moment. Let me check to see if I got any typo in the B over here. So if we look at from the header of a.ma, so beg your pardon, so this should be a.ma, right? I just noticed the error. In the case of b.mb, so here, since we're calling ma, so when we look at the a.ma, you can see as part of its header, it throws negative value exception. That's why we must handle that, either to specify it or to catch it, right? It's just a typo I made before. Now I fix it. You should fix it as well as you're typing with me. So for tester over here, we're done. Okay, so now let's make the method call. So we'll say ob.mb, and then whatever I it is from the user over here, we're going to pass it to here. And notice one thing here, you can see as soon as I do that, I don't have any red underline to say that the exception is unhandled because the callee b.mb, right? You can see b.mb over here. If I go back here, b.mb, you can see that one there. As part of its header, there's no throws negative value exception because it has been already caught the exception, right? So that's why any further caller of b.mb, they don't need to be subject to the catch or specify requirements. So that's really important for you to see, right? We already caught the chain about handling the exception already here. Okay. And let's now go back to the tester, and then you may just want to say input.close over here to get rid of the warning. Okay. Okay, so that's about it. Let's now try to trace the code very quickly, and now recap, and then we are done. And then we should move on to version 2 and version 3 relatively more quickly. Let me now simply put a breakpoint over here, ob.mb over here. Let's just put it here. Okay. and then I will debug it. Okay, so debug tester over here. If I click on that, all right, so let's not worry about this line here. So let's enter some integer value, right? Of course, this is a typo, but I'll fix it later. Okay, integer value. So let's say if I enter -10, right? It's a negative value, so that will eventually trigger some error from a.ma. Hit enter, and then I'll be switched to the debug perspective. So now I'm here, right? I want to show you two things. Okay, number one, if I simply say step over, I will be able to do it. And then I simply got an output over here from b.mb negative value -10. So this line here indicates that this line was printed from b.mb, right? From that particular callee, from there. And number two, I don't see the exception, negative value exception being thrown to the console. So these are the two things I want you to note, right? Let me stop the debugger and run it once more, and then I'll step into to show to you. If I launch the debugger once more, and then let me enter -10 again. Okay, so now rather than stepping over, let me now step into. If I say step into over here, I'm now in the callee of b.mb, right? You can see b.mb. You can see the call stack over here. The bottom is the tester domain, which calls b.mb, and then you can see the top is exactly b.mb, right? You can see the call stack, which we spoke about also earlier. I want you to get also used to it. It's quite important for your understanding. All right, so here b.mb is going to define the callee a.ma. So you can see here is a try block oa.ma over here. One thing to note very quickly, right? You can see if you move your cursor over I, it's -10. So we know that we can expect a.ma, if you remind yourself, a.ma, if I is simply less than 0, eventually we're going to throw this particular exception, right? Let me just go back to b.mb. So now a question for you, right? This will test your understanding about the flow. As soon as I say step over, what's going to happen? Since there's no more lines for the try and catch block, if that was the normal flow, it's simply going to end the try and catch block, try block, and then ignore the catch block and go to the end. That's the normal flow. The abnormal flow is going to be if an exception is thrown from over here, let's say negative value exception specifically, it's going to bypass the rest of the try block and then execute the catch block and then go for the rest of the program. Which one is it going to go? Well, seems like it should be the latter, right? The abnormal flow. So if I say step over, you can see it will go into the catch block, meaning that this exception here has been caught. And then we're going to execute this from b.mb negative value. Right? That's exactly what we saw in the earlier run for the debugger. Okay? One more run for completeness. And then for the later two versions, you need to really run the debugger yourself. Okay? Let's now debug once more. Let's say -10 over here. Let me now step into b.mb. Okay, so now I'm in the b.mb and step over, and let me step into also a.ma. Okay, let me basically I'm stepping into the method that originates the exception. If I say step into over here, now I'm now in a.ma. And because I here is actually smaller than 0, -10, so if I say step over, now I'm going to throw that particular exception, right? As soon as you see that over here, you can see now I immediately go to the catch block over here because that exception has been thrown to the runtime. So the runtime system will look for the exception handler in the call chain, right? So let me just remind you very quickly. As soon as the exception, negative value exception was thrown from a.ma, is immediately passed to the caller in the call chain, right? And in that case, b.mb actually got a catch block. That's why it's caught over there. Okay, so after this, we'll simply just execute this message over here. That's exactly what you saw, right? All right, so that's about a detailed tracing to show you. You should really try to reproduce this yourself. Otherwise, you cannot really be sure that you really understand what's going on here. Okay, let me go back to the Java perspective. We're now done with the coding for version number 1. Let me recap very quickly. Okay, so for version number 1, what we are doing is, you can see this oa.ma. So this is the callee. that actually throws the negative value exception. How do I know? You can see this is exactly the line that will actually throw that particular exception. So that's the one. Okay, as soon as this is actually thrown, it's going to be caught over here, right? The negative value exception. That's one point. And the second point is this. Okay, let me just say here to be more precise. B.MB, B.MB already handles the negative value exception. So here in the tester.main, the further caller over here, when we try to call OB.MB, right? So this is the point I want to draw to here. So tester dot main does not need to catch or specify it, and it over here is the negative value exception, right? So that's about version number 1. And of course, if you see the call stack over here, let's recap once more. This is where the negative value exception is thrown, and we propagate it to B.MB, and B.MB itself already got the exception handler, the try and catch block. So that's why it will be handled exactly just over here. And the exception will not, that's why we didn't draw this, it will not be propagated to tester.main, right? That's why you can see the call stack. Of course, this part of the arrow is simply just about how the caller-callee call chain has been formed. All right, so hopefully you're okay, and that's about version number 1. Let's now move on to the next 2 versions to see how the exception can be handled in a different place.